Got a 2016 school bus here with Cummins ISB. It's got a 5655 failed SCR code in it. It's had a couple of repair attempts. It's had, I think, a new def injector, a new pump, fresh def. So it's had a couple of swipes at it, but it does look like it's going to be a failed SCR. So let's look at some data. If you look at the left side of this screen here, you'll see, we are dosing. The next piece of data up, def line pressure is 130 psi. That's good. You can see engine RPM and throttle angle. Above that, you'll see SCR temps in and out. But most importantly on this, you'll see inlet and outlet NOx on top. And if you look at the data, we're roughly 50% NOx reduction. And that's not good, right? Federal spec is 85% NOx reduction. Easily, for fast and easy math for your own purposes, you can look at this and go, 90% NOx reduction. So if you got, 100 parts per million up front, you should have 10 out the back. You just kind of move the decimal place over one, and those are rough numbers, but they certainly work for diagnostics. And you can see we don't have that. Again, 120 out of the engine, 60 out the tailpipe. And as we're on the gas and off the gas, or basically, not necessarily throttle related, but engine load related, you'll see NOx jumping up and down. You just saw it dive to very near zero there. So looks like my NOx sensors are good. When I'm off the throttle and in injector cutout, I have almost no NOx out the tailpipe. And so we've got this short road test going on. And in a second here, we're going to start climbing a hill. And we're going to have, full throttle here, steady state for a little while. And we're going to look at these numbers again. So you can see here again, closed throttle, inlet and outlet NOx, 0 parts per million, both front and rear. And so I'm confident that my NOx sensors aren't out of bounds. They're reading normal numbers, and when I lift, they both go to 0. All right, so you'll notice I'm cutting the playback speed in half now. I'm doing this so I have time to talk about this, and so you can see what's going on. We're now climbing a steady hill with this bus. So we're wide open throttle. You can see accelerator pedal position's 100%, 114 parts per million NOx out of the front, about 46, 48 or so out the back. So a little more than 50% reduction. Again, that's terrible. Now, a couple of things can cause this, right? I could have poor def quality, and so it's not working in the SCR, it's not making any ammonia, and I'm getting poor reduction. I could also have the def injector not squirting enough def. I could have enough def crystals in the way that even though my injector's firing, those crystals the def isn't misting and going down the exhaust. It's hitting the crystals and just turning it into liquid, and it's going to solidify itself there. And so anyway, I could have lots of things that can happen in order to get me poor def reduction, but I need to find out why. So what I'm going to do, it makes a really fast diagnosis, is I'm going to add a gas bench. So now that's where the picture's going to start bouncing around, and I didn't do this for the entire recording because it's a pain to try to watch the numbers. So let's switch to the gas bench. All right, so here we're going to hit an acceleration on a hill. You'll see the little time delay. So I got 126 parts per million out. We're at 60 because we were just coasting. You see 40, 35. We were just light load going down a little dip. You're going to see it's take a little bit of time for this to catch up. Remember, we're going to school bus, man. It's also have to get all the way to the back, get pumped all the way back up to the front. So, see, we got our over 100 parts per million. Now the gas bench is starting to catch up. See, right over 100 parts per million. It was matching what this one had. All right, we don't need to keep watching that video bouncing all over the place in order to describe what's going on here. So I just wanted you to see the process of actually using a gas bench to help diagnose SCR problems. So what we've got is a 50% NOx reduction I can see clearly on the scan tool, and I verified that that is exactly what we have for NOx going out the tailpipe with the gas bench. So that does a couple of things for me. It verifies that the NOx sensor is good, but I can't verify that it's bad this way. And if you watched any of my other videos, you've seen that if we have unreacted NOx out the tailpipe, I'm also going to have unreacted DEF out the tailpipe. And because that outlet NOx sensor can't tell the difference between the two, it adds them together. Got 100% crosstalk with ammonia and NOx on these outlet NOx sensors. So let's say, again, for argument's sake, I had 100 parts per million out the front, 100 parts per million out the tailpipe, and a totally dead SCR. I'd really be reading 200 parts per million on the outlet NOx sensor because it's measuring all the unreacted NOx and all the unreacted ammonia. So I don't have that in this case. I just have poor NOx reduction, and I don't appear to have any ammonia out the tailpipe. So that led me to believe that we had poor DEF injection. So I thought maybe low pressure possibly, but we see that on the scan tool. It's not the case. Or maybe the DEF injector has got low volume, or a host of other reasons for not getting DEF in the tailpipe, right? But so that's what I was figuring. So we pulled the DEF injector, ran a volume test on it, came up 2.9 ounces, exactly where it needed to be. It's actually the minimum, but that's where they all test on these, is 2.9 ounces. And so we were good. A brand new one will test at that same number. So it's not a problem with DEF injection. We pulled the decom tube off. It was good. There's no DEF crystals inside the SCR. And so what this is, and this is unusual, it's why I really like this video, because you're never done learning new stuff. This is a failed SCR, but it still has a good slip catalyst. And so while I do have poor NOx reduction, I don't have the corresponding high ammonia out the tailpipe, because if my slip catalyst is working like it's supposed to, it's going to consume it all. So this was a first for me. I have a failed SCR and outlet NOx and on the scan tool and outlet NOx on the gas bench actually agree. So kind of a cool diagnosis. Again, first one for me, and but it's fast and it's accurate as long as you can actually measure NOx out the tailpipe and then know what those numbers mean. So thanks for watching my video, and please be sure to post any questions or comments below.